simulations and conclusions. So, the object of study in this article is the absorption of CO, CO2, and CH4 in activated and pure graphite. They use computer simulation to compare the amount absorbed in these two types of configuration. Based on the computer simulation studies reported so far, the most appropriate method to study the gas absorption isotherms of such materials is grand canonical Monte Carlo simulation. About the techniques, they use NPT Monte Carlo simulation with Widom method. This method calculates the excess chemical potential, which is the difference between chemical potential of the system being used and and if the gas were an ideal gas. After that, they use grand canonical Monte Carlo simulation to calculate the amount absorption gas. And they use Lennard-Jones potentials with charts, and they use Cyanomics Maps platform and TAUI simulation package. Describing the methods, here we have the graphite model. The bond length of carbon is 0.1421 nanometers. The graphene interplanar space, which is this distance, is 0.335 nanometers. And the box, the dimensions of the box system, the cell used is that 64.2 angstrom per 74.1 angstrom per 54.3 angstroms. The simulation cell consists of 3 parallel graphite sheets at different surface densities. The activation sites were randomly distributed. They introduced carboxyl and hydroxyl groups to activate the sites. Here we have the Lennard-Jones potential parameters. They use each model of each molecule they use from previous articles, and as you can see, the carboxyl groups have 3 Lennard-Jones sites and 5 charge sites, and the hydroxyl groups have 1 Lennard-Jones site and 3 charge sites. The simulations were performed at 298 Kelvin and different pressures in the range from 0.1 to 60 bars for CO2 and to 18 bars for CO and CH4. They run 3 million steps to each NPT simulation to obtain equilibrium, and additionally 3 to 6 million steps Is that me? Okay. 3 to 6 million steps to calculation of the chemical potential. For grand canonical Monte Carlo simulation, they do the same stats, 3 million stats to calibration of the system, and then another 3 to 6 million to calculate the statistical average. In this graph, we have the running average of the number density from a typical grand canonical Monte Carlo simulation of CO2 in activated carbon. These were here we have snapshots of the simulation boxes of the absorbed gases in graphite pores with activation site density of 2.22 at 298 Kelvin. Here we have CO2 at 22 bars, is a gas, and here we have the CO2 at 30 bars, which is a liquid. And here we have CO at 18 bars, and here methane at 18 bars too. This picture gives us a visual perspective of the physisorption phenomenon. As we can see, gases are mainly absorbed near to the wall surface of the graphite. These graphics show basically the same thing that the previous one. They show the density of absorbed molecules with the position in the cell system. So we can see again that the molecules are mainly absorbed near to the walls here in this. Now we have the simulated absorption in isotherms at 298 Kelvin. Looking at the graphics, we can observe that the amount of gas absorbed follows the order. CO2 absorbed more than CH4 that absorbed more than CO, which is in agreement with a previous study made by the same people. This part of the isotherm, it's called capillary condensation phenomenon. So the paper has no citations yet, according with Google Scholars. But how could it happen?
That is really rude. I'm sorry, you should wait till the end of class. You should not come in. I'm sorry. That is rude. Especially when someone's giving a presentation. I'm sorry,
So,
But I mean, it's a classroom, so somebody would have given a presentation anyhow. Sorry, now I'm going to be rude. I've stood outside classes before thinking, I need my keys. They're in there, but I've got to wait till the end of class to get my keys.
That's totally true.
Yeah, Americans.
So, the article doesn't have any citation yet because it's very new. It was published about 2 months ago, but I think will have some impact in the field because of the study. So they create a model, and that is that.
But did they do a good